So in this video I'm going to be solving past paper questions related to the topic of 3D volumes and areas. Okay, it's a fairly simple topic. You need to memorize some formulas and you need to know when to use them, and you are all set for this topic. I suggest you also have a scientific calculator next to you. In order to do the complex calculations which we shall be undergoing. Not really that complex, they just involve decimals, and for the sake of time we're going to use a calculator in order to reduce the amount of time. Okay, so let's start with the first question. Okay, so the first question is asking us it's saying that the diagram shows a sandpit in a child's play area. The shape of the sandpit is a sector of a circle of radius 2.25 meters and sector angle 56 degrees. The first question is asking calculate the area of the sandpit. So it's basically asking calculate the part which I just shaded right now. Okay, so or the way how you would solve it is, or first let's dissect this. Okay, so a sector of a circle is basically a part of the whole circle. Okay, so if you were to redraw this, you would be drawing a circle around it, and this part over here is the center in the circle. This is basically the radius, this value, and therefore this value over here, or this length over here, would also be 2.25 meters. Okay, so the formula for finding the area of a sector is x over 360 multiplied by pi r squared. Now pi r squared you guys are already familiar with. This is the formula used for the area of a circle. However, this part over here is unfamiliar. The reason for this is that you guys know that a point, the value or the degree a point has, the angle is 360 degrees. Okay, this value is 360 degrees, and a circle from its center has a value of 360 degrees. Okay, so now the part which the sector is taking up is going to be multiplied with the area of the circle, which will therefore give us the area of this sector. So this is the reason why this part is here, the angle of the sector. So this is basically the angle of sector, and this is always going to remain 360 unless there's another calculation which I'll talk about in further videos. Okay, so this is the angle of a point. Okay, so now let's use this formula. So x is 556 degrees over 360 multiplied by, we'll leave this aside for now, pi r squared. Now r is 2, so therefore 2.25, so therefore 560 multiplied by pi multiplied by 2.25 squared. Now let's just do this part first. Okay, so what you're going to get is, you're going to use your calculator now. 2.25 squared, and that you must get. We're going to use full numbers with all the decimal places if it is a rational number, and you're going to get 5.0625 pi multiplied by 56 over 360. Now you're going to multiply 5.0625 by pi, and you're going to round it. In this case we're in the middle of a calculation, so let's round it to 5 dp. Okay, so since we're in the middle of a calculation, so now when you multiply 5.0625 by pi, you're going to get 15.9043 331. Yes, that's it. Multiplied by 56 over 360. Now let's calculate the value for this 56 over 360. 56 divided by 360, which shall be 7 over 45, which is a recurring decimal. So we'll rewrite this. Multiplied by again 25 dp, and that shall be 0.15556. Then we multiply this answer by 15.90431, and you shall get, round it. In this case we're getting the final answers, or I'll just write this here, final answers in IGCSE. You will round them. There are some exceptions, but always to 3 significant figures. Sig figs, okay? 3 significant figures. Okay? So now we have 2.47 is the answer. And again, since it's meters and area is calculated in the SI, or the unit squared, so meters squared. So that is the volume, that is the sector of this area over here. Okay, now let's move to the next question. So we have this. Okay, now the sand pit is the sand pit is filled with sand to a depth of 0.3 meters. Calculate the volume of the sand pit. Okay, now this involves us knowing the formula if it's a prism, and so I'm going to draw this sector in a 3-dimensional shape. So the sector is basically, it's going to be something like this. So this is, let's say, the sector. It's not, it's just, let's just write not to scale. Okay, and then you have this part over here, and okay, so it's kind of like a slice of a cake. Okay, you can imagine, oh yeah, that would be a really good example. Okay, so imagine that this part over here is the thickness of the cake, 0.3 meters. Okay, this again, this is the angle of the sector, 56 degrees, and this is the radius, 2.25 meters. 2.25 meters is basically the distance from the center of the cake to its outwards. Okay, now one of the reasons, this is like out of topic, one of the reasons I may be talking about this is it's Ramadan. So anyway, let's get back to the cakes. So as we did in the first question, part A, we were able to find, using the formula, the area of this shaded area, and that was 2.47 meters squared. Now for prisms, or the volume of prisms would be, or is, the area of cross-sectional, or the cross-sectional area multiplied by length. Now in this case, the cross-sectional area is the sector itself. This is equal, or if you drew let's just draw an imaginary line. This, if you cut if you were to cut the slice of cake, or this sector, into two from here, you would get 2 equal parts if this, or since this is 0.3, this would be 0.5, and it's 0.5 if it was cut in half. So therefore the cross-sectional area is this, okay, and this area over here, and therefore this is a prism. So what we're going to do, and the prism, or we know the cross-sectional area, which is the area of the sector, and now we just need to multiply it by the length, which, let me just use a different color, which is 0.3 meters. So from this calculation over here, we are going to take that answer, meters squared multiplied by 0.3 meters, and as I said, we need a scientific calculator for this. 2.47 multiplied by 0.3, and you shall get 0.741 centimeters cubed, and this is three significant figures. Three significant figures. Okay, I don't know why it's so hard to write these three significant figures. Okay,